Hello everyone, at first take my salam. Assalamu alaikum. I am Muhammad Ubaidullah, ID Nong 19152702, Section Retake A, Department of CSC, Daffodil International University. Today I am going to discuss my presentation. So, first of all, my presentation topic is decision trees. A decision tree is a type of algorithm used for making decision based on data. Think of it like a flowchart where each step or nodes represent a decision point that leads you to next step, eventually arriving at the final decision or leaf node. It represents decision and decision making process in a tree like structure where each node in the tree representation and a decision based on the particular features attribute, and each branch represent the outcome of the decision. The leaves of the tree represent the final decision or prediction. Key components of a decision tree. Root node. This is the topmost decision point in the tree. It represents the starting point where the first decision is made. Decision nodes. There are points where decisions are made based on the data feature each node represent a question or test about the data. Branches. These are the possible outcome of a decision node. Each branch leads to another decision node or a leaf node. Leaf node, terminal nodes. These are the end of the points of the tree represent the final decision or outcome after all the decisions have been made. How decision trees work. Splitting the data. The algorithm starts at the root node and splits the data based on the feature that provides the best separation between the different classes for classification or outcomes. For regression, the best feature is usually determined by some metric like Gini impurity and information gain for decision task. Recursive process. The algorithm continues to split the data recursively at each decision node, creative branches, until one of the stopping criteria is met, like reaching a maximum depth. Having too few samples to split further all the data in a node belonging to a single class. Final decision. When the algorithm reaches a leaf node, it assigns the most common class for classification or average the value for regression of the data points in the node as the final decision. Common variables and improvements. Random forest. An ensemble of the decision trees typically used to improve accuracy and reduce overfitting by averaging prediction from many trees. Gradient boosting trees. Another is an enabled method where trees are built sequentially, with each new trees correcting the errors made by the previous ones. Advantage of a decision trees. Easy to understand and interpret. Decision trees can be visualized and understood even by non-expert. Handle both numerical and categorical data. Non-parametric. They don't require assumption about the understanding data description. Can capture non-linear relationship between features. Disadvantage of decision trees. Overfitting. Decision trees can easily become too complex and overfit the training data if not properly constrained through peering and limiting depth. Instability. Small changes in the data can be lead to large changes in the structure of the tree. Bias. They can be biased toward feature with more levels or longer numerical range. Conclusion. The decision trees are powerful and versatile tools for both classification and regression problems, but they are required careful tuning, pruning, spawning, and criteria to avoid issues like overfitting. Thank you, sir, watching this video.